What they are saying is that the pressure, if you see these weights on the piston are basically the constant pressure. So if you see the pressure has been maintained constant, and I'm heating the gas. When I'm heating the gas, the temperature is increasing. When the temperature increases, the volume also increases. Are we clear?
Yeah, sir.
वैसे भी तुझे समझ आया?
जी.
And usually again in school exams they might ask you. See, these are the kind of things that they usually ask in school exams. So, for example, they might ask you that list out various real life examples of Charles law. Now, in Charles law, you can give very simple examples. So, I'll try to explain this helium balloon thing with you. So, it says that if you have chance to go on a chilly day, you might have noticed that the balloon crumbles. However, if you take the balloon to a warm room, it regains its shape. Have you understood, Avantika, what he's trying to say?
Yeah.
So, for example, in colder countries, if you take this helium balloon, you are inside the room. The balloon would have the same shape. So, say it would have a shape like this when you are inside the room. But when you take it outside, when it is chilly outside, this helium balloon will sort of crumble. Is it making sense, Avantika?
Yeah.
See, the pressure is the same because the atmospheric pressure is the same. the the number of moles of helium in the balloon is also constant. But what has changed is the temperature. The temperature inside would be more. Let us assume the inside the temperature is say 25 degrees Celsius. But when you go outside, the temperature changes to say 0 degrees Celsius because we are talking about a cold country. So here, if you see, the temperature has reduced drastically, and consequently, the volume also decreases. Are we clear, Avantika?
Yeah.
So at times they might ask you a question based on real life examples of Charles law. So again, this is a beautiful example. Actually, that is what they were trying to do when they found all these laws. So hot air balloon. So hot air balloon. If you have ever observed, there is a burning flame here. Have you ever seen a hot air balloon? This is one thing
Yeah.
on TV. So when the temperature increases, the volume increases. Now, how this works is if you see any of these documentaries, etc. So for example, this is the ground. So these balloons, they are just lying on this ground, and then they start the flame. They start the flame. Now, as they start the flame, this balloon starts to expand. It takes a shape like this. Have you understood, Avantika?
Yes.
Because the volume has increased, the mass of the gas has remains the same. Mass is same. So therefore, density would decrease. Is it making sense? Because density is mass per unit volume. The volume has
Yeah.
increased, but the mass has remained the same. Therefore, density
Mm.
would decrease. Because density has decreased, as per buoyancy, as per buoyancy, now this balloon will start to rise up. Is it making sense?
Yeah.
It is just like you will see, so for example, the bucket in your bathroom, you take your mug, the plastic mug, and invert it and try to push it inside the water. It will always try to rise up. Why? Because the density inside is low. So similarly, so any lighter object, basically any lighter object will always try to go up in a medium whose density of air is more than density of gas or air in this balloon. Is it making sense?
Yes.
In very simple terms, if it is getting confusing, warm air rises up. Rises up. Why? Because its density of warm air is lesser than density of colder air. Am I making sense of one thing?
Yes.
So these are the sort of real life examples of Charles law. I will send you this page. You can have these two examples are there. Third example you can take like this. So if you have a tennis ball which gets crumpled, one of its side gets dented, just place it in a warm water. It will regain its shape. Similarly, they have taken an example of from a colder country that most of you might have observed that basketball, when left outside on a cold winter night, shrinks in size. Again, the example of Charles law. Am I making sense, Avantika?
Yes.